85% of America's corn once shared a single genetic flaw. In the summer of 1970, a fungus found it. Fields went from green to dead in days. Florida to Minnesota, all at once. Indiana farmer Melvin Flugg walked out to 600 acres and found half of it gone. Before hybrid corn, America didn't grow one type of corn, it grew thousands. Every valley had its own. Dent corn for livestock feed in Iowa, flint corn for meal in New England. Flour corn for tortillas in the Southwest. Bloody butcher with its deep red kernels in the Appalachian foothills. Farmers saved their own seed every harvest and replanted it in the next season. They selected for what worked. Drought tolerance here, early maturity there, better flavor for cornbread somewhere else. The genetics were diverse, regional, and farmer controlled. No two fields were identical. No two valleys grew the same corn. Then Henry A. Wallace changed everything. The son of an Iowa farming family, Wallace began experimenting with cross-pollinating corn lines as a teenager. He challenged the conventional wisdom of the time that the best-looking ears produced the best seed, and proved through yield trials that appearance had nothing to do with performance. By 1924, his hybrid, a cross between two open-pollinated varieties called Leeming and Bloody Butcher, was out-yielding everything else in the Iowa State yield test. In 1926, he founded the Hybrid Corn Company in Des Moines. It would later become Pioneer Hybrid, the largest seed company in the world. Wallace himself would become Secretary of Agriculture and then Vice President of the United States, still holding a financial interest in the company he'd founded. Hybrid corn was a genuine breakthrough. Yields doubled, uniformity improved, fields matured on schedule, making mechanical harvesting practical. But the catch was built into the biology. Hybrid seed cannot be saved and replanted. The second generation loses its vigor, producing unpredictable, lower-yielding plants. Farmers who adopted hybrids became customers, buying new seed every single year from the companies that controlled the parent lines. By 1942, hybrid corn covered nearly 100% of Iowa. By 1960, it was the standard nationwide. 1,000 open-pollinated varieties, each one a living archive of local adaptation, gave way to a handful of commercial hybrids bred for yield and uniformity. The seed companies profited, the diversity vanished, and nobody noticed what had been lost because the yields kept going up. But the seed industry wanted to cut costs even further. They found a way, and that decision is what made 1970 possible. Picture the summer of 1970. The blight started in Florida in early summer. Warm, humid air carried the spores north up the Mississippi Valley. By mid-July, it was in Georgia, Alabama, Mississippi. By mid-August, it had engulfed the entire southern corn belt and was pushing into Iowa, Illinois, Indiana, Minnesota, and as far east as Maine. The speed was staggering. The fungus moved north faster than the growing season. Stand at the edge of a field in southern Illinois that August and watch it happen. Tan lesions appear on the lower leaves first. Small, oval, spreading. Within days they merge, covering entire leaf blades until the green is gone and the plant looks scorched. The stalks weaken and snap at the base. Pull back an ear husk and the kernels are blackened and shriveled, the cob rotting from the inside. Multiply that by 1 million acres. County after county, the fields that were green in July were brown and collapsing by September. Illinois alone lost an estimated 250 million bushels of corn. Some southern states lost more than half their crop. Flugg told reporters they'd be lucky to have enough corn left to pay the fertilizer bill, and he was one of thousands. In total, the blight destroyed roughly 15% of America's entire corn harvest, approximately 710 million bushels, worth over $1 billion. Adjusted for inflation, that's $6 to $8 billion today. It remains the greatest single-season economic loss from a plant disease in American history. The stock market panicked. Corn futures spiked. Meat, dairy, and poultry prices rose as the feed suddenly collapsed. President Nixon was briefed. The USDA scrambled to assess how much corn was left, and everyone, farmers, traders, scientists, waited to see if the weather would break. One agricultural economist at the Federal Reserve Bank of Chicago said it plainly. Despite all the technology at our command, everything hinged on whether the next 2 weeks would be cool and dry. So what was the decision that made all of this possible? Producing hybrid seed requires detasseling, physically removing the pollen-producing tassels from the female parent rows in every seed field by hand to ensure controlled cross-pollination. It was labor-intensive and expensive. In the 1950s, breeders discovered that a genetic trait called Texas male sterile cytoplasm, cms-T, could make corn plants sterile without detasseling. The plant simply couldn't produce viable pollen. Seed companies could skip the labor entirely. The economics were irresistible. By the late 60s, cms-T had been bred into the genetic background of between 85 and 90% of all hybrid corn grown in the United States. Almost the entire American corn crop shared one cytoplasmic gene, and there were warnings. In the Philippines in 1961, 9 years before the epidemic, researchers noticed that corn carrying cms-T was unusually susceptible to a fungus called Bipolaris matus. They designated the new strain Race T. By 1969, the same disease appeared in cornfields in the southern United States. Plant pathologists flagged the connection. The seed industry had already committed its production lines. The 1970 crop was planted before anyone changed course. I started pulling the records, expecting a natural disaster. What I found was a decision made by an industry, ignored by a government, and paid for by the farmers who had no idea what was in their seed. I kept thinking about the absurdity of that moment. The most advanced agricultural system in the world brought to its knees by a single gene that the industry put there on purpose. The aftermath moved fast and revealed how fragile the system was. Seed companies rushed to produce non-cms-T seed over the winter of 1970 to 71, growing emergency crops in Hawaii, Mexico, and Argentina, but there wasn't enough resistant seed to go around. Illinois farmer Carl Thompson reported in the spring of 1971 that he'd only secured about 25% normal seed, and he was better off than most of his neighbors. A black market and blight-resistant seed developed. Farmers who had it charged whatever they wanted. Farmers who didn't planted what they could find and prayed. By 1972, nearly all hybrid corn had been converted back to normal cytoplasm. Using the old detasseling method the industry had tried to eliminate. One company, Fungus, had never adopted cms-T in the first place. They'd kept hand detasseling in their seed production. Their hybrid G4444 became the most popular corn in the Midwest almost overnight. That year, U.S. corn yields hit a new record. The crisis was over in 2 seasons, but the lesson was written in $1 billion of destruction. In 1972, the National Academy of Sciences published a report titled Genetic Vulnerability of Major Crops. Its conclusion was blunt. The key lesson of 1970 is that genetic uniformity is the basis of vulnerability to epidemics. Plant pathologist A.J. Ulstrup wrote that no major cultivated species should ever again be molded into such uniformity that it is universally vulnerable to attack by a single pathogen. Farmers in Iowa filed a class action lawsuit against the seed companies, arguing that the industry knew about the cms-T vulnerability and failed to warn them. The suit was eventually dismissed on procedural grounds. The seed companies kept selling seed, and the report gathered dust. Here's where this story should end with a reassurance that we learned our lesson. I wish it did. Today, 4 companies control over 60% of the global seed market. The genetic base of commercial corn has narrowed again, not through cms-T specifically, but through the same economic logic that created the vulnerability in the first place. When breeders surveyed genetic diversity in 1969, the 6 most popular inbred lines accounted for 71% of U.S. corn acreage. The number of varieties available has increased since then, but genetic similarity among them has not meaningfully improved. A 2022 review noted that global dependence on a narrow base of corn belt dent germplasm remains a structural vulnerability. Meanwhile, most of the 1,000 open-pollinated varieties that American farmers grew before hybrids arrived are gone. Many were never conserved. An unquantified amount of genetic diversity was lost before anyone thought to save it. Drive through the Corn Belt today and you'll see the same view you saw in 1969. Row after perfect row, uniform, productive, and built on an architecture that assumes nothing will go wrong. Corn feeds the cattle, sweetens the soda, fuels the car, and fills the export ships. It is the foundation of the American food system, and underneath the green, it is still a desert, waiting for the next pathogen to find the door that the industry left open. In 1970, $1 billion of American corn died because the seed industry bred the same genetic shortcut into 85% of the national crop, and nobody acted on the warnings that were already in the file. The companies profited from the uniformity. The farmers absorbed the loss. The National Academy of Sciences published its verdict, and within a generation, the system rebuilt itself on the same logic. The report is still sitting there, and it hasn't changed. Once again, nobody opened it. I keep thinking about the 1,000 corn varieties that used to exist before all of this. Most of them were never saved. I'm truly invested in finding out what else disappeared from the American ground the same way. Subscribe if you want to come along. Thanks for watching.